hope that we're at a tipping point when it comes to climate solutions and renewables in terms of the recognition that these are necessary. And I just feel that there's a lot of interest in the space. I think if you know what you're doing and you identify a problem, it is a great time to be a founder in the climate space.
Welcome to the Climate Tech Startups Podcast. I'm your host, Matt Zothner. We're chatting with Samantha Shiells, founder and CEO of Gigaflow. Gigaflow's platform simulates interconnection outcomes at different sites on the distribution grid for mid-market solar, storage, and EV charging developers. Thanks for hopping on. How are you doing today?
Hey, Matt. I am doing great.
Great to hear. I want to jump in to learn about Gigaflow. But before we get into that, can you give a primer on your background and sort of how you got to Gigaflow?
Yeah, sure. So my background is on the business side of software, most recently at Blueprint Power, which was a distributed energy market optimization platform for buildings. Previously, I was COO of a company called RA in a Box, and we made compliance software for small to medium-sized wealth managers. And I also went to business school and did private equity investing and some consulting before that. So I got to Gigaflow via Blueprint. I really, as I was leaving RA in a Box, really wanted to transition my career into something climate related and got connected to Blueprint, and that brought me sort of into distributed renewables, which is where I am now with Gigaflow.
And so when you were at Blueprint, you maybe saw some pain point that customers or partners were facing. And so you decided, hey, I'm going to take on this journey as a founder in the energy space, in the distributed energy space. Can you talk about how you came up with the idea?
So Blueprint's customers were real estate owners. And the thesis was kind of like, well, you own all this real estate, you might as well put DERs, so distributed energy resources, primarily solar and storage, but you can kind of lump EV charging and flexible loads into DERs depending on how broadly you want to define them. So you own all this real estate, you might as well, make use of it, make some extra money using DERs. And what we found was that, and we had a whole market optimization platform the idea was to value stack different markets. I won't go into energy markets too much, but the idea was that Blueprint software could optimize those assets for profitability. But what we realized was not a lot of buildings have DERs, and DERs are not super easy to just add to a building. On a model, the revenues might look great, but once you actually go to try to develop a project, like actually put an asset in a location, it gets much more complicated. And that was kind of when I first learned about the interconnection process. I just got really interested in development and all the things that kind of we weren't really seeing at Blueprint because we were mostly doing modeling and market modeling. And really, so it was as I got more interested in development and started to talk to more developers that I learned about the interconnection problem.
And so these developers, they want to see a return on investment, obviously. There's a high upfront cost to building these distributed energy resources, attaching them to their real estate project or wherever they're trying to get connected. Can you quickly explain to the audience, let's say no one knows what the interconnection queue is. Could you quickly explain what that is?
Yeah, sure. It's, in some ways it's not, in some ways it's not that complicated. In some ways it's very complicated. It's basically just the way that any energy project connects to the grid. Any energy project has to connect to the grid unless, except in a couple of very specific circumstances. And the best way to kind of understand the interconnection queue problem, it's a queue, so it's a line. So, if you have a project you want to interconnect, you submit an application to, depending on how big it is and where it is, like, let's just say you submit an application to the local utility, and they'll tell you, how much it's going to cost to interconnect if you can interconnect that project. And historically, you had a lot of large power plants that would interconnect to the grid. Maybe a given utility would process a couple of applications a year. And now with a lot of kind of changes that are happening in the market from the emergence of renewables, just like our aging infrastructure in general, load growth, that number has gone from a couple a year to hundreds. And the queue has gone from something that, was just a processing tool that wasn't really thought about much to this like massive problem in the industry.
Okay. So that's the basic explanation. I know it can get much more complicated. It sounds like there's a litany of issues here. In your opinion, would you say that the problem with the queue is more red tape from local governments? Is it a technology problem? I think this is probably what Gigaflow is starting to help with, but I'm curious to learn specifically what the main issues are with interconnecting.
Yeah, it's hard to pick one issue because there are just so many issues. It's really hard to say because there's not like one thing that would solve the problem. And there have been various kind of process changes that have been introduced in certain places that have maybe helped in certain ways.
Mhm.
I can maybe focus a little bit on what Gigaflow is trying to solve and the problems that Gigaflow tries to address, which is really lack of data.
Mhm.
So I'm going to say generator, but it could be
Mhm.
solar or storage. It is difficult for a generator to know where is a good location to interconnect because there's not a lot of information shared about that. And it's also a highly technical process of evaluating these projects for interconnection. And a lot of developers don't have sort of like the expertise in house that the utility has. So a lot of times they're kind of flying blind, and it's leading to a really high withdrawal rate and a kind of a lot of wasted effort on both sides. The developers, of course, they don't make any money if they can't get the project to they can't get a signed interconnection agreement. That project dies, it doesn't become a project. And then the utility is reviewing a lot of applications for really no purpose, because if they don't interconnect, then the utility just wasted a bunch of time. So that's really what Gigaflow is focusing on, to help developers better site projects given the kind of current regime of how the utilities evaluate projects for interconnection. But there are a ton of other issues and improvements that could be made to that process, that would allow more projects to be interconnected for less money, allow the system to be more dynamic, reduce wasted time. So there are a lot of potential improvements to the process. And Gigaflow is really focused on the data piece and being able to, in the future, when hopefully these improvements are rolled out, accommodate those into the kind of modeling engine so that they are also reflected in the range of results that a developer might see.
Lots of inefficiencies, but Gigaflow is currently tackling the data piece. So you analyze the grid, whether that's using, I guess, satellite technology. You look at maybe first and third party data sources, and then you're able to tell these developers, hey, this is the amount of time or money it will take to put this project online. Is that how Gigaflow is working?
Yeah, we're not tackling the time problem so
Mm.
far, just because that's not what the model is set up to do. It's really an infrastructure upgrade model with different rules for what triggers an upgrade, and then what that upgrade should be in different scenarios, and then what that upgrade should cost. The idea is that it will run a study that is trying to replicate as closely as possible within reason what the utility is going to do. It will try to run an automated study across various locations of the grid for different project sizes, not doing an optimization because that honestly takes too many computing resources. So really just running threshold sizes to give developers an idea of where their type of project, their size of project, could interconnect cost effectively. And yeah, it's really trying to replicate what the utility is going to do once that application gets submitted as closely as possible, so that you don't see this. I didn't really quantify the problem, but you don't see this in some areas. Up in New York, I ran the numbers in 2023, up to 90% withdrawals for projects. A national average is probably more like 75%, but still pretty high. The idea is to, if you knew the results up front, then you wouldn't need to go through the process of submitting an application and everything that happens before that. It would just be a lot more efficient for both sides.
Wow. So most projects actually just don't go through at all. It's highly inefficient. These are wild numbers.
It's funny to even call them projects because
Mm.
they're really site control. So getting site control is not insignificant. A developer has to go has to find a landowner or a real estate owner if it's rooftop,
Mhm.
get them to either sign a lease, they have to negotiate some sort of lease agreement. Maybe it's not a lease, maybe it's a letter of intent, but either way, they have to negotiate some sort of agreement. And if it's an attractive area for whatever reason, there might be other developers that are trying to negotiate with this landowner. So it's not insignificant to get the site control that you need to be able to
Yeah.
submit an application. But other than that, it's the design is fairly preliminary. There's not really financing there or anything like that lined up yet. So to call it a project, it's really a land it's really a land position.
Yeah.
But to get a land position is not an insignificant investment of resources for a developer.
Yeah. And so when the developer first sets out to control a site to do this letter of intent for these projects, we'll call them,
Yeah.
how long does this typically take to first, I mean, you can give averages here, like to first secure the site and then start to put the project together for, let's say, a utility scale solar? Is that like a year or much longer?
I mean, that's a good question. I don't know that I have a great quantification of
Hmm.
that timeline, like how long it takes to secure site control. I know that typically there's almost like an analogous to an outbound sales process where they're
Hmm.
sending out mailers. They're hoping that somebody responds to the mail. They're hoping that a landowner responds to the mailer. If so, they'll probably go out there in person. Evaluate the site for kind of other non-interconnection factors. So
Yeah.
make sure that, and they'll, before even actually sending out mailers, probably this is maybe where would Gigaflow or other tools come in. Make sure that
Yeah.
the site is suitable before sending out those mailers. So depending on how you're doing that analysis, how much analysis that is,
Mhm.
that could take quite a long time. And then the negotiation with the landowner, finding somebody who is responsive, that could also take a long time. I actually don't have a good number on how long it takes, but I do know that it is a pain point, and particularly one thing I've heard more than I've heard the time is the cost of land in attractive areas is going up, and deals are getting land deals are getting more
Yeah.
competitive. So for a developer to invest in securing a site when there are other developers potentially interested it is a cost in time, but also in resources, like financial resources, as the sites get more expensive. And in some cases, I have heard, I don't think this is as common, but I have heard, some owners don't really want, like, they may just not be interested, but they would be interested in selling. And then they have to evaluate, maybe find a partner who wants to potentially buy the real estate and then lease it to them because the developer's
Yeah.
probably not going to buy it. But if it's a good site and they can find a way to make it work, the deals can get complicated. But
Very much
I
so.
think it's,
Yeah.
yeah, I don't know. I don't know the exact timeline.
Yeah. And then so these real estate developers or the project developers, they might be able to secure this piece of land. But then there's still the fact that 90% of the projects fall through because of the queuing process. So they have no guarantee that any of this is going to work. Hopefully, Gigaflow and others can help sort them out with the right amount of data. And so the project sizes you're talking about, what are the capacity? So I know you have expertise in 100 kilowatt to 10 megawatt. Saw that somewhere on LinkedIn. Is that the typical size that you're working with?
Yeah, for sure. So Gigaflow is really focused on the distribution system. The term utility scale typically would apply to the transmission system.
Hmm.
And the reason that Gigaflow is focused on the distribution system is that my background is in distributed energy. So I just happen to think that it's an attractive market and that there's a lot of untapped potential in the distribution system. But there's certainly an interconnection queue problem at the transmission level as well. And it would just be kind of different data sources, different analytical methods, and whether a project connects to the distribution or transmission system is it's like correlated to the size of the project, which is why I give that kind of 100 kilowatt to 10 megawatt guidance. It's not a hard and fast rule because it also depends on local regulations. For example, in New York, you can only go up to 5 megawatts. In other
Um,
areas, you can go up to 10. But for developers, if you can only go up to 5, but maybe you find two plots of land right next to each other, put 5 megawatts on each of them, then it's like effectively a 10 megawatt interconnection from the developer's perspective because of the rule, the law, it has to be split into two parcels. So it really just depends on if it's connected to the distribution system and it's large enough to have the potential to cause network problems to require network upgrades, that would be a Gigaflow project.
So you're parsing all this data so that you can sort of personalize these insights to the specific project at hand, which is useful, right? Because every utility or a municipality might have different rules and regulations, so it can get very inefficient if you're not giving them the right data. I want to switch the conversation a little bit to sort of just talking about building a climate tech startup. In this energy space, what would you say are some trends that are happening that people should be aware of?
In energy specifically, or in kind of climate tech startups investing?
In the
So
distributed energy space?
Yeah, well, okay, in the distributed energy space, there is definitely a lot of growth in distributed energy. Really, distributed energy wasn't a thing before solar and storage, because you can't have like a distributed gas power plant. I mean, I guess there are peaker plants, so maybe you can sort of, but so just the rise of distributed energy is a major trend, and of course, like what Gigaflow is trying to take advantage of. Some trends in climate tech. I do think that energy has been kind of a bright spot in climate tech startups with sort of a more challenging interest rate environment. I've seen and heard about a lot of pullback in even climate tech investing. However, I think because there is so much opportunity in energy, I mean, we're seeing load growth from electrification, from the AI, which I mean, our whole system hasn't seen load growth in, I don't know, like 20 years, maybe more. Not a load historian, but this is what I've heard.
Yeah.
It's just a really like exciting time to be in distributed energy specifically because of all these dynamics that we mentioned earlier. What's causing the interconnection queue to be problematic is also what makes distributed energy exciting, which is that there's a lot of activity, there's a lot of development, there are a lot of renewables coming online, there's a lot of potential if we can just actually kind of get these projects to move through and be sited in the appropriate places so that they can actually get built. So yeah, I would just say like a lot of excitement, and what's causing the problems is all the activity. So it's good to see we need to change the current paradigm so that we're not just seeing a lot of front end activity, we're also seeing actually solar and storage get built.
Yeah, lots of tailwinds, especially with all the load growth. Data centers, GPUs trying to do all this GPT computations. So there's a lot happening in the space and a lot of capital moving in. Let's say Gigaflow is super successful and we're 20 years in the future. Yeah, fingers crossed. Startups are hard. You're saying the interconnection problem is not, it won't be fully solved, but what does the future look like if Gigaflow succeeds?
Yeah, well, so certainly what Gigaflow is banking on is that some of these process changes come online and be implemented, because there's no future where we don't do that. We would just not be able to connect any resources, and unless you believe that we'll just basically halt on progress towards like our decarbonization progress, there's just no way that some of these changes don't get implemented, because the current situation is just unworkable. And there is certainly a recognition on the federal level by FERC, starting to happen at the state level as well, which is really kind of what governs the distribution system, state level policies and state level public utility commissions. So these things are definitely happening. One of the most exciting things that I am anticipating, and which Gigaflow will certainly be able to take advantage of and assist with, is what's called flexible interconnection. So right now the standard at the distribution level is just but they don't even say firm interconnection, because that's just what it's just. Interconnection is just like how French fries, just firm interconnection. In France, they don't call them French fries. Just firm interconnection, which means you have a certain capacity, and that is the maximum capacity, like the nameplate capacity of your project, and that is how your interconnection is evaluated. And it's really a worst case scenario evaluation. So if we're talking about solar as an example, you are exporting your maximum nameplate capacity at the period of minimum load on the system, which would be sort of the worst, the time when the infrastructure would be most strained potentially. However, that may never happen, or it might happen like 1 hour a year. And so with a flexible interconnection, you could maybe solve for just that one worst case scenario time period and avoid the upgrade that would be needed to accommodate that, for example, 1 hour a year by just curtailing your power that hour. And that would be just written into the interconnection agreement. It starts to make interconnections more complicated because you need a more dynamic system, and you need to, right now, not really using a 8760, like an hourly load model to evaluate interconnections, which you might start to have to do in a flexible interconnection scenario. But that would open up a ton more capacity. I've heard estimates from like 20 to 50% more capacity available from adopting flexible interconnection policies. And so I think that would make a huge difference, and it's certainly something Gigaflow could take advantage of. Yeah. So when I look into the future, I see a much more dynamic distribution system, and hopefully Gigaflow could even be, operating assets as part of an aggregation and bidding into a distribution system operator, which is a model that doesn't really exist yet. So at the transmission level, we have the independent system operators in like about 2/3 of the country, and there are markets. It's a much more like dynamic system. You can bid into a wholesale market, you bid into a capacity market, where it's at the distribution level that doesn't really exist yet. However, certainly, I mean, 20 years, that sounds kind of like a reasonable timeline to have distribution system markets, and that is something that Gigaflow will definitely be able to play into. Kind of almost like when I'm bringing my blueprint experience back to Gigaflow, be able to actually not just optimize the interconnections, but also optimize the market participation when those two things can kind of come closer together. Right now, interconnection is a little bit static, the way it's approached, but certainly I see it becoming more dynamic, and that's definitely something Gigaflow will be able to take advantage of.
Great. A dynamic system is best for all players involved, and I hope Gigaflow can be a part of that change. We're running out of time here, but my last question for you is just an advice question. So we're all in this early stage startup game. Do you have advice for founders who are trying to get into the climate and or energy space?
Yeah, I do. So I mentioned when we did the introduction that I was coming from a compliance software background for wealth managers, which is not at all in energy. And this was in like 2018. And I really wanted to transition my career. So I would say to somebody who is in that position, it's definitely possible if you're coming from not a climate or energy background. And all you have to do is really just like learn the space, decide what you're interested in, and then go deep in that area. Climate can be pretty broad. You can have water, agriculture, energy, direct air, carbon capture. Yeah. There's just like a total, it's almost a kind of economy in itself with potential climate solutions. So kind of pick one lane and go really deep in that, because if you're trying to found a company, you really want to make sure you understand what you're founding. And climate is broad. There's something to be said for kind of really understanding what you're doing. And that's if you're coming from not a climate background. If you have experience in the area, that's definitely a huge advantage, because there is a lot of interest from investors and especially talent. I find I get a lot of interest, a lot of inbounds from people who are interested in working in climate or in energy, in renewable energy. So I think, for founders, if you have a good idea and you really understand the problem, I think you have a kind of good shot at building a business, because you'll certainly be able to attract people that are interested in it, because this is really the time that I hope that we're at a tipping point when it comes to climate solutions and renewables, in terms of the recognition that these are necessary. And I just feel that there's a lot of interest in the space, even, if climate tech investing is slowing down a little bit, with interest rates. But I think if you know what you're doing and you identify a problem, it is a great time to be a founder in the climate space.
Yeah, a lot of talent moving in. You could argue that any company can be a climate company. And yeah, I know that we met through an accelerator, so there's lots of opportunities to get some of that business education and or advice from people who've been in the space. So don't be scared to hop right in and start a company.
Yeah, for sure. I would add to that, make sure you know what you're doing, because I think there's, at least maybe in traditional tech, an underappreciation of understanding the problem and what you're doing before jumping into solving it. So definitely, if you're interested, make sure you understand the specific slice of climate that you're going to take on, because there is a lot of complexity, and I think knowing what you're doing is underrated.
It's a great
But
place
if you
to
do,
end.
if you
Knowing what
have
you're
that,
doing is underrated.
yeah, exactly. But once you have that knowledge, it is a really great time. It's very exciting. Like there's so much energy. Climate Week, when we're taping this, Climate Week is coming up next week,
Yeah.
and every year is bigger than the last. So it's just a super exciting time. And yeah, if you know what you're doing and you have an idea, this is definitely the time to execute it or try to execute it.
Yeah. Great stuff. Thank you for your time, Sam.
Thank you. Thank you so much, Matt.